In this video, we'll look at another trigonometric substitution. Let's start by rewriting the original integral just a tiny bit to see clearly which substitution we're going to make. I'm going to rewrite the 4 as 2 squared. That way we can see that we have a variable squared plus a constant squared. In this case, the substitution that we make is x equals a tangent theta, where a in this case is 2. So we have x equals 2 tangent theta. Then the derivative is 2 secant squared theta d theta. Now we can rewrite that integral. In the denominator, we're going to replace the x with 2 tangent theta. And that quantity is squared. And 2 squared, I'll replace that with 4. dx we replace with 2 secant squared theta d theta, which I will put on the outside. Since we changed the variable, we need to change the limits of integration. We started out with variable x, the lower limit was 0. So if we make x 0 and solve for tangent, we can divide by 2, we still get 0. We're asking when is tangent 0? That's at 0. So the lower limit stays 0. Initially, the variable x had an upper limit of 2, so let's replace x with 2. Divide both sides by 2, we'll get 1 equals tangent theta. Now you're asking when is tangent 1? That's at pi fourths. Now that we have our limits of integration, we can continue simplifying this expression. I'll leave the numerator as it is for now. And the denominator we can rewrite as 4 tangent squared theta plus 4. Continuing to focus on the denominator, I'll just copy the limits and copy the numerator for now. Remember, the goal in the denominator under the radical is to get a perfect square. That's our ultimate goal. So we'll start by factoring out a 4. We'll be left with tangent squared theta plus 1. Again, copying everything in the numerator for now. Recognize that tangent squared theta plus 1 is a trig identity. That is secant squared theta. Continuing to simplify the denominator, we'll continue to copy the numerator, and the denominator we get 2 secant theta. At this point, we can simplify. The 2's will reduce, and one of the secants will go away. We'll be left with one of them in the numerator. So we have the integral of 0 to pi fourths secant theta d theta. Now that we've simplified, we can actually integrate secant theta. The integral is the natural log of the absolute value of secant theta plus tangent theta, and we are evaluating from 0 to pi fourths. We'll have the natural log of, let's plug in the upper limit pi fourths. The secant of pi fourths is square root 2 plus the tangent of pi fourths is 1. Then we need to subtract the lower limit. Secant of 0 is 1 plus the tangent of 0 is 0. Finally, we get the natural log of the absolute value of square root of 2 plus 1, since the natural log of 1 is just zeros.